Hello and welcome. So this is the second video I'm making on what I'm calling as bottom-up theory. So in the first video, I have put down my basic concepts of what this really means. So please go and see that video. I'll put the link in the comment section of this particular video. So we started with looking at the space part in the last video. Now we'll try to go further deep into that. So I'm calling this as space 2, this presentation or this video as space 2. And let us slightly recap of what my concept was about space. So as I said last time, so my postulate is that really real space and imaginary space come out of nothing, and then nothing means really nothing, no mass, no space, no time, no energy. And then as long as they are in equal volumes, they can get created. And the way they can get created, they can also get destroyed, as we'll also recap in next couple of slides. So on the left hand side, I've just put the real space in white and gray dotted lines, and then the imaginary space is in blue. So, and I will also put the axis x, y, and z, and also ix, iy, and iz. And we saw the equation last time as how the space can get destroyed or created from nothing or zero or shunya. So, so this is a small way of imagining things. So out of nothing, really the real and imaginary spaces. Here I am showing it as a complete overlap, but we also saw that there could be many other options. So they get created in equal volume, and then the way they get created, they can probably also get destroyed as I'm just showing here, and then what you get back is nothingness or zero or shunya. Okay, so this was what we talked about in the last video. Now let us move to the core part of this particular video. Okay, so what we are now going to look into is the core part of this video. So we said that space can get created from a point, and then I'm just trying to show this over here again. But now what you will see here is there are multiple such points and spaces getting created. Okay, so I put green dots in the center just to denote that this space was really spewed out from these points. And I also talked about that this need not be necessarily a cube. It could be a sphere, it could be anything. But what you see below is really important. I'm calling it as postulate, and I'll be calling postulates in in yellow in future videos also. So postulate, first part of the postulate is that no two space bubbles, I'm calling it as bubble, though it is looking like a cube, uh, of a type can overlap each other, meaning no real space can occupy another real space. So think of it as like really balloons, or uh, balloons filled with air, and then if you bring them together, so they can expand in other directions but not really overlap each other, right? So so something similar, but not exactly, but it's good for imagining. So no two space bubbles of same type means real, no two real can overlap each other. At the same time, no two imaginary bubbles also can uh, overlap each other. So they can be side by side, giving a feeling of a continuous space? Now, feeling to whom, right? So that is the obvious question you might ask, but we'll just park it aside. So unless we try to bring in mass into the equation, we cannot really imagine further on this. But let's keep it aside for the moment. So no two real spaces can occupy each other, and no two imaginary can occupy each other. But if it is real and imaginary, all types of overlaps are possible. So this is a complete overlap that we are seeing. And also we in the earlier video saw that there could be other ways of overlapping, a partial overlap or maybe a completely discontinuous creations. So let's move to the next slide, which is kind of a first deduction, not deduction, but a concept really. So think of this uh, like mini big bangs, okay? So mini big bangs is again a stupid word if you ask me, but because big bang means the big bang, right? But imagine as this space and this universe getting created at multiple points, and then we haven't put anything into the mix right now, so we need to put mass and energy and then all of those things together over here to really talk about the big bang the way we think of big bang. But just think of it like space is getting created at multiple places and then multiple at multiple times. Again, I'm using time very loosely over here because we haven't defined time, right? So we will go there. But just imagine that these are like multiple big bangs that might have happened in past, might be happening currently also, who knows. And then uh, if the spaces are completely discontinuous, then those are like different universes, right? Will never know about them. So and then in some cases this expansion of the space might be still happening, right? So it's still going on, and then who knows? So this may be still happening. At some places it may have got curtailed or it might have got stopped. And what this all means is this is finally going to define our concept of time and many other things. But we'll park it for some few episodes down the line. But here essentially what I'm trying to say is this particular space bubble is still expanding, right? It's going on. And what we'll try to do in next 2 or 3 slides is really try to put mass into the mix and see because are these spaces expanding or contracting, or who knows, right? We don't know other unless we observe, and then observation itself is a different topic. But unless we have at least for my imagination, unless there is some kind of mass over there, and unless we see what is really happening with that mass or masses, we cannot really say what is happening with space. So what I've tried to put here is uh, in the next few slides. So let's think of it now. I've just made one cube, right? So no dotted lines, just for understanding, and I've made it like blue and white just to denote that this is a mixed space of real and imaginary, and then it is completely overlapping. And I have to put two dots over there, right? So one is a red dot on the right hand side, and one is the green dot. So we already saw what the green dot was. Green dot was from where really the space was getting created, and now red is the opposite of that. So space is getting sucked into it or getting destroyed into that dot. So I will just put those two dots, and now assume that this space creation and destruction is happening simultaneously. Again, I am using the word simultaneous very loosely, but just imagine, okay? So what can probably happen is now what you can see, this whole cube is now getting deformed, right? So where there is this red dot, the portion over there is getting reduced, and where there is green dot, so on the left hand side of the green dot, it is maybe still getting expanded, but these two dots are also somewhat coming closer to each other, right? So essentially the space is getting deformed because of simultaneous creation and destruction of space. Okay, so these two dots are now we we may think that they are actually moving uh, in slightly different directions. So now what you can see here is like the space around that red dot is now really deformed, right? Because it got sucked in, and hence the shape of the remaining space is is very different now. And then I have just tried to roughly kind of deform it manually, but just to give you the concept that the space is not the cube that we thought earlier. Now it is quite deformed, and because of the red dot which is sucking the space, and the green dot which is actually spewing out the space. Okay, now I'm going to do one more thing as a teaser in this particular video, is that I'm going to put two masses over there, and then I've just put white masses over here. I'm just coming to that slide. Okay, now here it is, right? So this was our cube, original cube, and I have made it transparent so that we really see the uh, masses inside. So uh, I put two masses. One is closer to the red dot, which is sucking the space, and another is closer to the green dot, which is kind of creating the space. Okay. Now let's put the same deformation with masses involved in this whole mix. Okay. And these white masses, what they mean, these are real masses. And then how, from where did they come? How did they in the first place came here? Are there imaginary masses also? We'll visit it later, but let's assume that these are white masses and these are real. When I say masses, I'm talking about rest mass. Okay, by the way. So we still have to introduce motion to this whole thing, but just imagine that these are rest masses. One is closer to the red dot and another is closer to the green dot. Now if you see the same deformation which I was showing earlier, this mass which was closer to the red dot is now actually moving towards the red dot because the space is getting sucked, and the mass appears to move towards that red dot. Whereas the mass closer to the green dot has changed the position because overall there is this sucking up and then uh, spewing out of space is happening, but it is still kind of far away from green dot, but slightly maybe moved to the red dot. And then on the next slide, what we'll see is the third uh, deformation slide which you saw earlier, is that now the dot, the mass closer to the red dot is actually very, very close. So it's kind of reaching that point where this was, where the space has really got shrunk, or it's got destroyed. The whole geometry is also quite deformed now, and because I have made it transparent, you can also see the geometry that has happened. So now the mass which was closer to the green dot also has moved closer to that dot, but not that much, but it has also moved slightly to the right because space was also getting sucked up in that direction or getting destroyed in that direction. So so one possible conclusion which I have just put in there is that is this is this kind of explanation of expanding universe, at the same time what we call as black holes, right? So, and then simultaneously on one side it is expanding, but on the other side it is getting sucked up at a place, and what you see is the mass which is closer to the red dot. So what we see in black holes is lot of mass density, right, around the black hole or inside the black hole. So how dense it is and what it is, there are a lot of theories and calculations, but essentially what I'm trying to say here is, because this is essentially a space mechanism and we are sucking masses closer to the red dots, or maybe they turn out to be black holes, who knows, but we'll visit it later. So there is a huge concentration of mass, and hence uh, what we see there is huge mass density, and then because the space is getting sucked up, you also have this feeling of huge gravity possibly over there. And then we might be just misinterpreting gravity, where we are saying that because there is a lot of mass, the space time is getting curved and hence things are getting pulled. But it could be the other way around, right? Because the space is getting pulled, masses are getting together, and hence we are equating that to masses changing the space here. I'm still not talking about time. I'm just talking about space. So I'll leave you with that thought, and it's kind of a revolutionary thought, if you want to call. But essentially, what we are trying to say here is, space is getting created, space is getting destroyed, and if there are masses around, they are getting either pulled or pushed apart. And then this can really, I mean, go into explaining a lot of things, right? So one is gravity, one is anti-gravity, which your uh, dark energy is really responsible for, as scientists say. But let's visit all those things in more detail in coming videos. So I'll leave you with that thought here, and put whatever you think about this in the comments. Uh, Thanks, and then I'll shortly coming up with the next concepts on this bottom-up theory in the coming episode. Thank you. So just before ending this part, I would request you to subscribe to this channel, where I'll be putting more such videos. So if you are interested in physics, fundamental physics, particle physics, quantum, whatever, please subscribe to this channel, and I'll be putting in my own original concepts and research through these videos. Thank you.